Okay, let's go to the next exercise of the sets, that is exercise 1.6. Okay, so before proceeding to the problems, let's go through some formulas, okay, which are used to solve the union and intersections. Okay, that is called the practical problems on union and the intersection of two sets. Okay, that is the practical problems on a union and intersection of the two sets. Okay, for solving all the problems we will go through the formulas. Okay, now see, we have learned that, say, if a equal to a set, say a b c d e f g, okay, and if b equal to, say, 1 2 3 4 5, and if c equal to say 2 4 6 8, okay, like this. Now these are the elements of the set A, and this is the element of the set B, and this is the element of the set C. Now how many elements do we have in each set? Okay, that is the total number of elements. You see, this is 1 2 3 4 5 6 7. We have 7 elements in set A. Okay, and here you see we have 1 2 3 4 5. We have 5 elements in set B. We have here 1 2 3 4 elements in set C. Now how are these denoted? See, the number of elements of A is denoted by n of A. Okay, n of A means, which is read as number of elements of set A. Okay, in the same way, number of elements of set B, number of elements of set C. Okay, this is written as number of elements of set B is 5, number of elements of set C is equal to 4, and number of elements of set A equal to 7. Okay, this is how it is written. Okay, now see, let's look at the Venn diagram. Okay, see, if this is, let's take color. See, if this is a set A, okay, and this is a set B, okay, this is B and this is A, okay, and the whole thing is in the universal set. Okay, now if you see this part is A minus B. Okay, this part, okay, this area is the A minus B. What is A minus B? All the elements of A, all the elements that belongs to A but does not belong to B. Okay, B is up to here, so this area is A minus B. Only the elements of A belongs here. Okay, and this area is B minus A. Okay, only the elements of B but not A. Okay, and this area, what is the center area? What is this? This is A intersection B. Okay, this is A intersection B. Okay, now if you take again this both in the same way, okay, this is A minus B, this is A intersection B, this is B minus A. If you take this whole, color this whole two together, all the combination, what is this? This is A union B. Okay, A union B is the total combination of both the set A and B. Okay, this is A union B. Now see, this A union B can be written as A minus B, okay, plus A intersection B, okay, plus B minus A. Okay. Okay, we can write this in this way. Now the total number of elements in A union B can be denoted by how we denote elements of A, set A and set B. N of A is the total number of elements in set A. In the same way, the total number of elements of A union B can be denoted by N of A union B. N of, okay. The same way, the number of elements of A minus B, total number of elements of A minus B, only of this, can be written as N of A minus B. Okay, this can be total number of elements of A union B can be written as N of A union B. So this can be written as N of A minus B, and the number of elements in the intersection region area can be written as N of A intersection B, and of the B minus A area can be written as N of B minus A. Okay, so the total number of elements of A union B is equal to number of elements of A minus B plus number of elements of A intersection B plus number of elements of B minus A. Okay. Okay, so this is the formula which is used to calculate the total number of elements of A union B. Okay, now we will just derive this and change this formula to an easier or simpler version. Okay, that is if you see, let's add and subtract N of A intersection B to this. Okay, so let's add. Okay, now this is the formula which we have received, okay, to calculate the A union B. Okay, number of elements in the A union B. Okay, in A union B. So now let's modify this, okay, to a simpler version. For that, let's add and subtract N of A intersection B, okay, to this in the right hand side. Okay, so we'll get N of A union B equal to N of A minus B plus N of A intersection B plus N of B minus A. Now add and subtract, plus N of A intersection B minus N of A intersections B. Okay, we will add and subtract this one. Okay, now if you see A intersection B, now if you see the total number of elements of A, okay, total number of elements of A, N of A, okay, will be this area plus this area. Okay, that is N of A minus B, number of elements of A minus B, plus number of elements of A intersection B, A intersection B. Okay, number of elements of A, this total number of elements of A will be A minus B plus A intersection B. Okay, A minus B plus A intersection B. So you see, we can write this A minus B and A intersection B, this as N of A. Okay, so this is this one. Okay, this can be rewritten as N of A. So, and in the same way, you see this one, B minus A, the total number of elements in B minus A will be, in the set B will be B minus A plus A intersection B. The number of elements in B set will be N of B minus A plus N of A intersection B. Okay, so you see N of B minus A, N of A intersection B. This is N of B minus A plus N of A intersection B. So this can be written as N of B, and this can be written as N of A. Okay, so we can rewrite this as N of A union B equal to n of a, okay, plus n of b, this one minus n of a intersection b. Okay, now this is our new simplified version of the formula. Okay, these both are equal, okay, both are same, but this is a little bit simplified one. So this is our formula, okay, number one. Okay, formula number one. Okay, now you see, now this here, these are joint set. Okay, these two are joint. What if this is disjoint? You know, disjoint sets. Okay, that is, this is a set A, okay, again, and this is a set B. Okay, and you have the universal set U. Okay, now this is A and this is B. Now what is A intersection B? A intersection B, there is no intersection. This is called disjoint set. Disjoint set. Okay, so what is A intersection B? Here we don't have A intersection B. That means the common elements between A and B is nil. Okay, we don't have any common elements, so that is empty set. Okay, this is an empty set. A intersection B is empty. That is, set is empty. So what will be the number of elements n of A intersection B? Number of elements will be 0. No, okay, no elements. Okay, so when it comes to this disjoint sets, then our formula will be, see, n of A intersection B, the number of elements of intersection part is 0, so this will be simply 0. Okay, so for this type of disjoint sets, the total number of elements of A union B, okay, number of elements of A union B is equal to n of A plus n of B. Okay, in this n of A plus n of B, and this is 0. We don't have common elements, so this will be minus 0. So it can be written as n of A union B equal to n of A plus n of B. Okay, that's it. This is the formula number 2. Okay, so we have two formulas to find the total number of elements of A union B for both joint and disjoint sets. Okay, joint set and disjoint set. Okay, that's it. Now let's see the next formula.